Till now, we have looked into basic version 1 architecture of Internet of Things. We have also looked into what is a smart device. We have understood property of smart devices. Let's look into some of the use cases of IoT. We have already seen the example of smart fire management system in a smart building. So smart fire management system is just one of the component of smart building. When we say smart building, a smart building may have multiple smart systems. If you take example of any building, we will see that there are many functions which happens in a building. For example, lift, electricity supply, drainage system, water supply. There are many such functions in a building which needs to be managed. And if we want to make a building smart, we have to make these subsystems smart. A building requires security, building requires fire safety, fire management, building requires lighting, building requires 24 by 7 monitoring, building requires energy management, and many such functions. So in order to make a building smart, we need to make all these subsystems in the building smart. And how do we make anything smart? We have already seen that. We make anything smart by collecting data and taking smart decisions based upon the data. So first step in making anything smart is implementing IoT devices to collect data. Implementing IoT devices with sensors, they will collect different kind of data depending upon different functions. So for example, in the earlier example we saw where the temperature sensor is there, which is collecting temperature. Similarly, you can have sensors which can monitor the functioning of lift. You can have sensors, it can monitor the functioning of drainage, the flow of drainage, similarly the flow of water, flow of electricity, and there could be multiple cameras which would be monitoring various kind of movements for security purpose. By implementing all this kind of devices, we can capture different kind of data. Now once we have this data also needs to be communicated. The IoT devices, they need to communicate to the backend system where some processing will happen, and then from backend system the command or the communication has to come to the IoT devices in order to perform some action. So we need to have a communication system. It could be local LAN, it could be some cellular system, Wi-Fi or wired system. Most of the time nowadays it is Wi-Fi system because it's more easy to implement. But in many situations there could be wired network communication as well. So you have data, you are collecting data using IoT devices. The data or the information is being communicated with the between the devices and the backend systems. And then we need the compute infrastructure where all your data which is getting collected needs to be stored, there needs to be processed. You need to perform different kind of analytics. This could be there in some local data center. The information could be there on some cloud, and there could be some edge devices also. So we will talk about what is edge and cloud and different layers of processing in a while. But as of now, for simplicity, we can say that we need some kind of compute infrastructure to manage and process all this data in order to take smart decisions. So data management and analytics is one big area which needs to be done, because all this data which are coming from different devices, until unless you process the data, until unless you do some analysis on the data, you will not be able to take smart decisions. So smart decisions is all about collecting data and then analyzing the data to getting insight from the data and then taking smart decisions. So we will need big data management systems because there could be volumes and volumes of data coming. For example, if you have a building premises where there could be hundreds of cameras, and all the images which are coming from cameras, all the videos which is coming from data, that may be enormous amount of data. This data needs to be analyzed for operational efficiency, for predictive maintenance, and then there could be real-time monitoring required. All this data which is coming, real-time monitoring may be required, and then you will need application for consumers, for reporting purpose, for visualization purpose. So in order to make any building smart, there are various components of IoT based system, and this is how we make a building smart. Let's take another example. We have already looked into smart home devices. You have smart speaker, you have smart fridges. Nowadays we have concept of smart homes where you have a lot of automated things. There are motion based lighting system, there are smart meters, then there is a smart security systems. Your home is being monitored using security cameras and sensors. So these kind of things are getting implemented, which we may be experiencing in our day-to-day life. In addition to smart home, we have so many smart devices which we may all be using. One of the very common device which all of us are using is smartphone. Smartphone is a wonderful device which has lot and lot of feature. It has so many different kind of sensors, and we all experience it on day-to-day basis. So these were two examples, but IoT has a wide range of application across all the industries. So one area is industrial IoT, IIoT. This is a subsystem of IoT, which is called industrial IoT, where the focus is smart manufacturing, smart production. This is also part of something called Industrial Revolution 4.0. If you know about Industrial Revolution started around 200-300 years back in Europe, and that revolution which started in Europe, that is today termed as Industrial Revolution 1.0. So 1.0 Industrial Revolution primarily focused on production, automation of production, and primarily focused on economies of scale. So Industrial Revolution 1.0 primarily focused on automation of production so that you can produce more and more goods at a lower price. The second era of Industrial Revolution, IR 2.0, Industrial Revolution 2.0, started with machine-to-machine communication, where the networking was evolved and different machine could send information to each other, and that happened almost 50, 60, 70 years back. The third industrial revolution is considered to be the evolution of internet and interactive web technologies. With evolution of industrial revolution 3.0, the interactive web technologies evolved, and that led to a massive explosion in the areas like online banking, e-commerce, and many other user applications. Now we are living in an industrial revolution 4.0. So there is no hard date or line. It is just a general way of saying industrial revolution 4.0 started around 7-8 years back, and the focus of industrial revolution is smart ecosystems. You have systems which are behaving like human. Today you have speaker which talks to you like a human being. Today you have a TV which talks to you like a human being. So evolution of smart systems is industrial revolution 4.0. So the technology which are dominating industrial revolution 4.0 is internet of things, blockchain, artificial intelligence, machine learning, big data analytics, cloud computing. So they are some of the technologies which are dominating the revolution, and they are the technologies of future. So apart from smart industries, we have smart transportation. There is something called IOV, Internet of Vehicles, where your vehicle, the smart system in the vehicle and the smart system in the traffic, they are getting integrated for improved logistics and improved transportation. For example, your car could sense the traffic light and it would stop automatically without your intervention. So you do not have to see traffic light. The car would sense the traffic light. So there would be some kind of integration of sensors which is there in the car and which is there in the traffic light. This kind of integration is happening in the smart cities. Wherever smart cities are getting implemented, smart traffic management, smart traffic light management, smart transportation is getting implemented. Then we have smart homes and buildings coming up. The smart homes and buildings, they focus on better energy management, better safety, better operational efficiency, and better facility management. And then we have smart cities. We all know that a lot of governments are investing a lot of money in smart cities. In India, there are smart city project is getting implemented across more than 100 cities. Dubai, New York City, Barcelona, Singapore. They are some of the example of smart cities which are already implemented. And then we have smart healthcare and remote patient monitoring. Today, there are wearable gadgets which patients can wear, and these smart gadgets, they will keep monitoring the patient's vital, and they will keep transmitting the information to the backend system. In case of any abnormality, the alerts will be thrown to the medical staff and immediate action can be taken. And this is being highly utilized by elderly people and sick people. So you do not have to go and stay in hospital. You can stay at comfort of your home, but the doctors can keep getting the information about you using these smart wearable devices. Then we have smart agriculture, where you have sensors which can detect the moisture in the soil, it can automatically start sprinkling water in the fields. So they can be integrated with the weather department. They can get the information on the weather prediction, and that information can be fetched to farmers, and basis that information, the smart decisions can be taken. And then we have security and surveillance. We already know about it. There are a lot of security cameras, different kind of security sensors which are implemented across the places. Specifically, we see that in our office complexes and residential complexes, but there are many different kind of security devices which are being implemented. And in our coming sections, we will go a little deeper from technology point of view, from engineering point of view. What are those components which is helping us to make all these things smart? And we have already seen some of those components just a while back. We will go a little deeper into these components. In terms of architectural component, what are the things which are needed? Number one is sensors, actuators, and device integration. So if you are working on an IoT project, this would be one of the key area. You have to integrate different kind of sensors which collect data. You have to integrate different kind of actuators which take actions basis the command given to it. And device is something which integrates your sensors, actuators with the backend system. Then we have cloud and edge integrations. We will go a little deeper into cloud and edge in a while. But cloud and edge is your backend processing engine where all this data which is getting collected, they needs to be stored, they needs to be processed, they needs to be analyzed. And all this mostly happens in the cloud or edge servers. Then we need networking, short distance networking, long distance networking. In case of IoT, one of the very important thing is low powered. LP stands for low powered and wireless communication. The evolution of IoT is directly proportional to the evolution of wireless technology. You cannot do so much of wiring when you are implementing something in wide area network. So wireless technology is the key behind evolution of IoT. Wired technology can only be implemented in a small area, in office complex, in residential complex. When we talk about implementing something in the area of agriculture, we are implementing something in the area of transportation. Wireless technology is the key, which is giving the boost to IoT based smart systems. Real time stream processing, all this data which is getting collected, it needs to be processed and monitored in real time. For example, you have security camera, so all the images and videos coming from security camera, they needs to be monitored in real time. Any kind of abnormality which is getting observed, we should get some kind of alert and alarm for it in real time. And then you also have big data management, because all this volumes of data which is coming, it needs to be managed. There are many big data management tools for storing the data, for processing the data, for analyzing the data, and those kind of technologies are being used to make systems smart. Then we have batch processing. One is you are getting data and you are analyzing, you are monitoring the data in the real time, but everything cannot be done in real time. So we need to analyze in batches also. We take data of last 1 week, 1 month, 1 year, and we do analyze that data, and then we see what is the trend. This is that we can do some predictive analysis to predict future. And then we have reporting and visualization tools using which you present all this data to the respective stakeholder, be it management, be it consumers, be it authorities. So they are some of the architectural components, and each of this area is a subject in itself. So somebody who is working as a IoT architect, somebody who is working as a IoT project manager, that person will have to work with experts in all these area and integrate all these components to implement the entire system. As an engineer, if somebody is working, you may be working only in one or two area. For example, somebody may be working in sensor integration. He may be expert and champion in sensors, so he may be working on the sensor integration part. Somebody may have expert in the cloud platform, so he may be working on the cloud integration. Somebody may be expert in some kind of stream processing engines like Kafka or Kinesis, and they may be working only on that area. So as an expert, you may be working in one or two area, but if you look at a high level, if you're working as an enterprise architect, if somebody is working as a delivery manager or a project manager or a program manager, that person needs to work with experts in all these areas and get things integrated to implement a end-to-end solution. It's also very important to understand that IoT, Internet of Things, is not about one technology or two technology. Internet of Things is an ecosystem which involves multiple technologies, and one need to understand end-to-end system and the various kind of technology in order to implement a efficient solution. Let's go into a little deeper of the architectural diagram which we saw earlier.